Good afternoon, good evening, ladies and gentlemen. Welcome to another series of tutorials. Today we have a very interesting question from one of my friends. So the question reads, if it costs a firm C of Q dollars to produce Q grams per day of a certain chemical, where C of Q is equals to 1000 plus 2Q plus 3Q to 3/2, the firm can sell any amount of the chemicals at $4 a gram. Find the break-even point of the firm, that is how much it should produce per day in order to have neither a profit nor a loss. Use the Newton method and give the answer to the nearest gram. All right, so this is a very interesting question. Now let me just break the question down for you so that you understand everything that is going on here. So it costs a firm C of Q dollars. So C of Q, let me see. So C of Q is the cost to produce. Okay, so the cost to produce. So this is the cost to produce. So C of Q is the cost to produce, and Q is the grams produced per day. Q produce per day. Okay, Q is the produce per day. Okay, now this is the cost function. Okay, meaning that to find the produce per day, which is Q, this is the function. All right, so now if the firm can sell any amount of the chemicals at $4 a gram, meaning that if they sell this chemical at $4 a gram, they are covering the costs of making the chemical. So if the firm can sell any amount of the chemical at $4 per gram, meaning that they're covering the costs, find the break-even point. Okay, the break-even point is where they are neither making a profit or a loss. Okay, so let me give an example. For instance, if we have 30 items, let me use the white. So if we have 30 items, okay, and if we can sell those items at $4 each, and when we sell those items at $4 each, we can make neither a profit or a loss. How do we know how much we're going to make? So basically we just multiply how much we're going to produce times how much we're going to sell. So same applies here. Q is the grams produced per day. Okay, and we want to sell those, we can sell any of those at $4. So to get the cost of production, we just say 4 times Q. So this will be equal to the cost of produce. Now the cost of produce, which is C of Q is equal to this equation here, 1000 plus 2Q plus 3Q to the 2/3. Okay, so meaning that 4Q is equal to 1000 plus 2Q plus 3Q to the 2/3. Okay, now what this means is that we can use this if we solve for Q. Remember, Q is the produce per day. Okay, and the question is saying that how much it should produce per day. Okay, find the break-even point, that is how much it should produce per day. So we are just going to solve for Q because Q is the produce per day. okay? Because here we are told that the break-even point, find the break-even point, which is how much we should produce per day. And Q, we said, is the produce per day. Now, we are basically going to, okay, if they didn't specify for us to use the Newtonian method, we would have used any method to solve this equation. All right, so now using the Newtonian method to solve this equation, so we take everything on one side of the equation and we introduce the inverses. We see that we're going to have 3q to the 2 over 3 plus 2q minus 4q plus 1,000. This is equals to 0. Then now from here we can simplify this, so we have 3q to the 2 over 3rd plus this would be minus, sorry, so this would be minus 2q plus 1,000 is equals to 0. So now to solve for q, using the Newtonian method, the nth q, or which is the nth q, is equal to, or let me say, okay, the n plus 1 q is equal to the current q minus f of q of n, which is the current q, over f prime of q of n. Okay, so what we're just going to basically do is that we are going to guess qn. We're going to guess qn. Okay, so looking at the number that we have here, what number do you think you can plug here and here can give you 100? Or let me say it can give you 0, sorry. So that number should be, if you can see the numbers, it should be close to 1,000 somewhere there. It should be close to 1,000. Okay, should be close to 1,000. So maybe let's try, if q is equals to 600, you can pick any number, and as you'll be going, but you can pick any number of your choice. But looking at the constant here, it will tell you the nearest that you have to go. So let's go halfway, maybe let's try 600. Let q equals to qn, or let's say q1 in this case. Say q1, let q1 equals to 600. Okay, now meaning that our n here is 1. Okay, so our qn plus 1, we put a 1 here, meaning that our q2 will be equals to our q1, which is 600, minus f of q1. Okay, so that is f of 600 divided by f prime of 600. F prime of 600. Now our f of q is equal to 3q to the power 3 minus 2q plus 100, or 1,000, sorry. So if we replace 600 in this equation,